Looking at section 2.4, algebraic reasoning. Our essential question: how can algebraic problems help you solve equations? So we start with introducing some of our properties. So the addition property, right? If A equals B, then A plus C equals B plus C. These are all properties you're familiar with. This is saying I can add the same thing to both sides. Subtraction property. If A is equal to B, then A minus C equals B minus C. Saying I can subtract the same thing from both sides. Multiplication property. If A is equal to B, then AC equals BC. Saying I can multiply both sides by the same thing. And the division property. If A equals B and C is not equal to 0, then A divided by C equals B divided by C. Saying you can divide both sides by the same thing, but we can't divide by 0. And then the substitution property. If A is equal to B, then A can be substituted for B in any equation. Right. So stuff that's been used in Algebra 1, in geometry we use this to introduce proofs. And we'll look at proofs more in the next couple sections. But a proof, we're looking at what we know and why we know it. Okay, so example 1 is what is known as an algebraic proof. Our proofs always start with the given. So in an algebraic proof, the equation they're giving us is our given. So I have 2x plus 3 equals 9 minus x. The reason I know that to be true is given, because it's my given information. Then I'm looking at how do I get to my next step. So here we're trying to solve for x. So just typical algebraic steps. So I'm going to add x to both sides. It gives me 3x plus 3 equals 9. And the reason I can do that is the addition property. Then I'm going to subtract 3 from both sides. So I have 3x equals 6. That is subtraction property. And then divide by 3, x equals 2. And I can do that because of the division property. If it helps to show what you're doing, like plus x to both of these, that's fine, but that is work. That does not get a reason. Your reason matches up with the line, and it's telling you how you got there. So it's not the next thing you're doing, it's how did I get to this line. Another one of the properties we can use is distributive property. So A times B plus C equals AB plus AC. Okay, where A, B, and C are real numbers. So that's saying we can distribute. Okay, one of the things with proofs, these can be in different orders if you're following proper steps. So if we look at the one above, I could have subtracted the 3 first and then added the x. And that would change what you have here. It would also change this order. What I'm going to go through is generally what I think is probably the way most people would solve these. So example 2, -4 parentheses 6x plus 2, ending my parenthesis, equals 64. That is our given information. Then I'm going to distribute the -4. So I get negative 24x plus, oops, I'll leave the plus there, minus 8 equals 64. And I know I got there by distributing. So that's distribution. Now I'm trying to solve for x, so I'm trying to get x by itself. I'm going to add that 8 to both sides. So I have negative 24x equals 72 by addition. And then I'm going to divide by the negative 24. And I'm going to get 3. X equals negative 3. And that is by division property. So that is our algebraic proof. Now on the next side, the top, we have 3 different properties. These get more in, these work with algebra, these get more into our geometry things. And we see these a lot. It's reflexive, symmetric, and transitive. Okay? And you can split them up for from what you're doing. So you can have like real numbers, segment lengths, angle measures. They'll pop up again when we talk about this in relationship to congruence. But for what I'll do is I'm not going to specify when I'm looking at reflexive, it's reflexive no matter what I'm looking at. Same with symmetric and transitive. So to go over what these properties are, reflexive property is just saying something is the same as itself. So A is equal to A. AB is equal to AB. The measure of angle A is equal to the measure of angle A. The same thing, it's the same thing as itself. Symmetric property is saying I can flip where things are on the equal sign. So A equals B is the same thing as B equals A. AB equals CD, so CD has to equal AB. Transitive property connects multiple things. So if A equals B and B equals C, then I know A is equal to C. The example I use a lot of times with transitive is height. If Joe is the same height as Sam, Sam is the same height as Bob, then I know Joe and Bob are the same height. Okay, that is our transitive property. Part of the reason we have these 3 properties is as we're doing geometric proofs, we need to explain everything we do or we're not allowed to do it. So example 3 is getting into a geometry proof. Right? And this is a fill in the blank proof. So AB is equal to EF. That is given information. Okay? And I'm given that by AB and EF being marked the same thing. What we're trying to prove here is that CF is equal to AD. Okay, so that's what we're going through to show. Okay. Then BC, if I look up here, I have the 2 dashes here and the 2 dashes here. So BC is equal to DE. Again, that is given information. Okay, so the given information can be stated as given or it can be drawn on the picture as it is here. Then AC is equal to AB plus BC. So if I look here, AC is equal to AB plus BC. That is the segment addition postulate, right, which I will, from this point on out, abbreviate SAP. Okay, that is saying I'm adding 2 smaller segments and getting 1 larger segment. So DF equals, if I look at DF, I have the same type of setup here, right? I have DE and EF. So DE plus EF is equal to DF. Again, that is segment addition postulate. Now the next line, it looks the same, DF equals BC plus AB, but BC and AB don't make up DF. So So that is not segment addition postulate. That is substitution. All right, if you're abbreviating substitution, make sure you use 4 letters. We also have subtraction, which is SUB. So you need the S and the T if you're abbreviating those. Then DF is equal to AC. This is transitive property. DF is equal to BC plus AB. BC plus AB is equal to AC. So DF and AC have to be equal. That is transitive. Okay. And now, looking at what I want CF equal to AD. I don't have CF and AD. I have AC and DF. But if I add CD in there, I have that whole thing. So DF plus CD equals AC plus CD. That is addition property because I'm adding the same thing to both sides. And then DF plus CD, that is CF. AC plus CD, that is AD. And that again is segment addition postulate. In the next section, we go over these rules some more. We'll look at proofs some more. But that is how our proofs work. Now, the last thing we have here is a word problem. Okay. And they ask us to solve the formula for T, find the amount of time, but it also says to make sure to justify each step. So we're doing this as a proof. Okay, so I have I equals PRT. That's my given. Okay. They give me some numbers here, so we're going to sub those in. Interest of $75,000 when the principal is $10,000. So I have $75,000. We have $10,000. And we have an interest rate of 7%, which is our R. Remember, when you're dealing with percents, you put it in as a decimal. So 7% is 0.07. And then I have time. So this, separate this some. This is my first step is my given. The second step is substitution. I'm plugging in numbers, so I'm substituting in. I'm going to combine these here. So 75,000 equals 700T. There's a couple things you can call that. It is not multiplication though, because multiplication is multiplying the same thing to both sides. This we're going to call simplifying. You would call it combining like terms. I'm then going to divide by 700, which gets me 10.71 equals T. That's division. And do they tell me to time the amount of time it would take? They don't say to round it to anything, so we can just leave it as 10.71 and be good. They said to the nearest year, you'd want to go to 11 years. They don't tell us that, so we're good with 10.71. And that is our introduction to proofs with algebraic reasoning.